Okay, welcome to today's lecture. Today's lecture is about balancing chemical equations. In this lesson, I'm going to teach you on how to come up with a balanced chemical equation. So pay extra attention so that you can understand clearly. So note that when balancing a chemical equation, it involves a certain amount of trial and error. So we'll be using trial and error method in order for us to come up with a fully balanced chemical equation. So sometimes you might discover that you're trying to balance a chemical equation, but it's failing to balance. So you just have to continue the process by trying using different what numbers on your reactants and on your products. So I'm going to teach you now that is done. So note that a chemical equation is made up of two parts. It's made up of the reactants and the products. So if at all you're trying to balance the number of atoms on your reactant part and on your product part, you need to use some numbers. You use some numbers. If you want, you can use two or three. You try. If at all those numbers are going to give you a fully balanced chemical equation. If at all those numbers are failing to give you, try using some other numbers. That's why we are saying when coming up with a chemical equation, it involves a certain amount of trial and error. So you just have to keep on trying by changing, using different types of numbers, so that you ensure that your equation is balanced. So I'm going to teach you all this. Just pay extra attention. So what else are you supposed to know here on balancing chemical equations? You need to know the steps that you're supposed to follow that can guide you in order for you to come up with a fully balanced chemical equations. So in general, however, you should follow these steps. So I'm going to show you the steps that you're going to follow in order for you to come up with a fully balanced chemical equation. So the first one, count each type of atom in reactants and the products. You need to count the number of atoms in the reactants and in the products. For example, let me give you an equation here. For example, you have in magnesium plus oxygen. It's giving us magnesium oxide like that. So here, what do? You need to, the first step when you want to come up with a fully balanced chemical equation, you need to count each type. You need to count the number of atoms on your reactants and the products. So here, I'm having Mg like that and O. So I'm having magnesium and oxygen. Even this side, I can write Mg and O. So that's magnesium and oxygen. So here, the number of atoms for this magnesium here, seen here. And note that this is the reactant part and this is the product part. So this side is product, then this side is what? The reactant. And then here you need to count the number of atoms for magnesium on your reactant part. So here we are having 1. Here there is a 2 down for oxygen, so it's 2. And then magnesium this side, here it's 1 atom of magnesium you're having, and then oxygen also 1. There's no number down there, so it's 1 like that. And then that's the first thing you're supposed to do. As this same thing is saying, the first step is saying count each type of atom in reactants and products. So just by doing that, then okay, and then you need to ask yourself a question: does the number of each atom appear on both sides of the halo? Like the number, does the number of each type of each atom appear on both sides of the halo? So have you seen the number of atoms this side? We are having 1 for magnesium. This side you are having 1 for magnesium on your reactants and your product. So in terms of magnesium, it's balanced. But what about in oxygen? In oxygen, we are having 2 this side, 2 atoms of oxygen, and then 1 atom of what? Oxygen that side. So what do you do now? So here, in terms of oxygen, the reaction is not balanced. On the reactant part, you're having 2 atoms of oxygen. This side, you're having 1 atom of oxygen. So we need to balance in terms of oxygen. We need to ensure that even this side, on your product part, it's 2. And then, if not, the equation is not balanced, and yet you need to go to step 2. So the first thing, you need to count the number of atoms. You count. After counting, you need to ask yourself a question: are the numbers the same? If they are the same this side, if at all you're having 1 this side, 1 this side for magnesium, it's balanced in terms of what about in oxygen? In oxygen, it's not balanced. So we need to proceed to step 2. If at all you had 1 here, even this side 1, then the equation is balanced. No need of balancing. So some equations are already balanced. You're not supposed to balance them. But here in terms of oxygen, it's not balanced. So we need to proceed to step 2. So what is step 2 saying? So step 2, you need to press coefficients as needed in front of the symbols or formulas to increase the number of atoms or molecules of the what substances. So that's the second step. You need to press coefficients. These coefficients are numbers in front of the symbols of formulas, in front of the symbols of formulas. So in front means this side, not behind. So when balancing, we're going to press the coefficients in front of the symbols or formulas to increase the number of atoms or molecules. So we need to ensure that the number of atoms on your reactants and the products are what? Same. So how can you ensure that this side we also having oxygen to be 2? Because this side it's 2, this side it's 1. So this side we can't make it 1, it's already 2 like that. So we need to deal with the product part this side. So what can you do? We need to press the coefficient as in front of the symbols of formula. So since this side oxygen is 2, how can I make this oxygen this side to be 2? So I'm going to press 2 in front like that, in front of the symbols of formula. That's what the step 2 is saying. So as you have seen here, when I place these 2 in front of magnesium, what's happening in front of magnesium oxide? So magnesium on your product, it will increase by 1, will increase by 2, sorry, it will be 2. Even oxygen, it was 1, but it will be 2 like that. So in terms of the products, we are having magnesium to be 2, it has changed, and then your oxygen also is 2, because this 2 is for Mg, which is magnesium and oxygen. So this magnesium oxide as a compound. So it's scattering for everything this side. So in terms of oxygen, it has changed to magnesium 2. But if you come this side, in terms of oxygen, it's balanced on your reactants and your products. But what about this first part? What do you do? On magnesium now, it has become unbalanced. It's not balanced for in terms of magnesium. So what do you do? So on your reactants, you can add 2 in front of magnesium now, like that. So you need to be changing. That's why we are saying when coming up with a balanced chemical equation, it involves a certain amount of trial and what? Error. So this is a trial and error thing we are using here. So here now, the equation is balanced. We are having 2 magnesium here, 2 magnesium there, 2 oxygen on the reactant part and 2 oxygen on the products part there. That's how you come up with the balanced what? Chemical equation. So on step 2, it's saying use the smallest coefficient as what possible. So we should be using smaller numbers as possible. But sometimes some equations you can even use big numbers. So 2, 3, 4, these are the numbers that I use. But mostly, but sometimes you might discover that the equation is requiring you to use big numbers. It's as simple as that. So let's do, and then the last part, the last step, repeat steps 1 and 2 until the equation is what? Balanced. So sometimes you can even be changing numbers. You try to use this number if it's going to make the equation balanced. If it's not balancing, just continue repeating the steps until you come up with your fully balanced what? Equation. So now let's do this exam what? Question so that you can understand clear. So the question is saying balance the following equation. So we have this first one which is saying zinc, which is a solid reacting with oxygen to produce zinc oxide. And then we have this one for iron reacting with chlorine to form iron 3 chloride like that. We have this one C, which is having lithium metal reacting with oxygen to produce lithium oxide like that. I also have D, which is having hydrogen reacting with oxygen to produce water like that. And we have E, which is having magnesium reacting with carbon dioxide to produce magnesium oxide and carbon like that. So let's do it now one by one. So let's try to balance this first one. So when balancing, let me come up with the solutions so that you can understand clear. So we're having zinc. So wait, I'll be writing down. So zinc as a solid plus oxygen, it's giving us zinc oxide like that metal. So how can you balance now? So the first thing, we need to count the number of atoms. We need to compare the number of atoms on the reactant part this side and on the product part. So I like coming up with this thing here so that it will help us. Even here in terms of zinc, we need to know oxygen like that. So here we need to know the number of atoms for zinc on the reactant. So it's 1. And then for oxygen it's 2 this side. Then what about zinc this side? Zinc this side it's 1. And then oxygen is also what? 1. So have you seen in terms of zinc, the equation it's balanced, but in terms of oxygen, it's not balanced. This side on reactant you're having 2, this side you're having 1. What do you do? So if at all you discover that you're not having the same number of atoms on the reactants and on the product, you need to proceed to step 2, which was saying that you need to add the coefficient in front of the symbols or the formulas, and these coefficients are numbers. So here we must balance in terms of oxygen on the product part. How can you make this oxygen to be 2? Note that this side on the reactant you're having 2, so we can place 2 in front of zinc oxide like that. But when you place 2 in front of zinc oxide, what's going to happen? You will notice that in terms of zinc will change now. We have a 2, we increase like that, because this 2 is for zinc and for oxygen. It's for this compound, zinc oxide. So, and then this 2 is also catering for oxygen this side. So in terms of oxygen, the number has changed this side on the product to be 2. So in terms of zinc, zinc has become 2, oxygen has become 2 on the product. What about on reactants? On the reactants, zinc is 1, but oxygen is what? 2. So in terms of oxygen, it's balanced on your right hand side and on your left hand side. And then what about zinc? How can you balance zinc to make it 2? Because this side on your product has become 2. So we're going to add the 2 in front of zinc like that. Therefore, this one will change now to become 2 like that. So just like this, that's how you come up with a balanced equation. So this side you have zinc 2, oxygen 2 like that, zinc 2, oxygen 2 like that. Then it's balanced. So let's do the other one so that you can understand clearly. So here we are having iron reacting with the chlorine to form iron 3 chloride like that. So how can you balance this now? How can you balance this? So let me just write it like this so that you can understand clearly. Plus chlorine like that, which is a gas, it's giving us iron 3 chloride like that, which is a solid like that. So how can you balance this? The first thing, we need to count the number of atoms. You need to compare the number of atoms on your reactants and on your products. So that's the first thing. And then chlorine, sorry. So just write it like the way it is, chlorine like that. Okay, that's the symbol. And then in terms of iron atoms, how many atoms of iron are you having this side? It's 1. Then chlorine atoms this side, it's 2. And then iron on your products, iron atoms, the atoms for iron this side on the product, it's 1. And then for the chlorine, how many atoms are you having? 3. So have you seen this reaction now? How can you balance? So in terms of iron, it's 1-1 on your reactant and your product, it's balanced. But in terms of chlorine, it's not balanced. But how can you balance it? That's the question. You need to ensure that in terms of chlorine, it's having the same number. So how can you balance that? So the first thing here, I need to come to the product, because you can't make these 3 to reduce. So you can't make 3 to reduce. So I'm going to come to this smaller number 2 on the reactants. So on the reactants, I can even use this 3 to write it somewhere here. So when I write 3 here, this means my chlorine has increased to be this 3 times 2. It's going to give me 6. Now this side, since my chlorine now on the reactant has become 6, how can I make chlorine this side to be 6 as well? Because it's having 3. I can just add the 2 in front there. Hope you're seeing what's happening. So this 2 times this 3 down you're seeing here, it's going to give me 6 as well this side. But as you have seen here, after adding these 2, this ion you're seeing here, it has become 2 as well. It has become 2. But this side on your reactants, what's happening? It's ion 1. It's 1. So how can you balance ion? So ion, you can add the 2 in front like that. So, and then it's going to be like this. It's going to be like that. So we have now balanced. On your left hand side, on your right hand side, the numbers are the same. So that's how you go about this. It is very simple. This is just a trial and error thing. So you just have to be thinking, just have to be sharp. You can use numbers, but you need to use smaller what coefficients, smaller numbers as possible. Okay, so now let's proceed to C. So here we are having lithium reacting with oxygen to produce lithium what? Oxide. So how can you come up with a balanced what? Equation. So lithium like that plus oxygen like that, oxygen gas, it's going to produce lithium what? Oxide like that. Now here, what are you supposed to do? First thing, you need to count the number of atoms on your right hand side and on your left hand side like that. So here, how many atoms of lithium are you having? It's 1. For oxygen, it's 2. And then this side, lithium, it's 1. Oxygen, 1 like that. So obviously in terms of lithium, it's balanced both sides on reactants and the products. But in terms of oxygen, on the reactant it's 2, this side it's 1. So how can you ensure that it's 2 even on the product? You can add 2 in front of lithium oxide. But when you add 2 in front of lithium oxide, lithium on the product, it will increase by 2. Also, oxygen will increase by 2. But in terms of oxygen, it's balanced. We're having 2 both sides. But lithium now, on the first part here, it's 1. How can you make it 2? This side on the product is 2. How can you make it 2? You can add 2 in front of what? Lithium like that. And then therefore, we're going to have 2 here. So that's how you balance. So it's balanced on the right hand side and on the left hand side. So let's do the other one. So let's do D, and I'm sure you're getting this. So here now, what do? Hydrogen is reacting with oxygen to produce what? Water like that. So let me write this equation so that you can see it clearly. So it's a gas to produce water like that. But water here they're written it's a gas, but water can be a liquid, not so. Okay, so here what are you supposed to do now? You need to count the number of what? Atoms. For hydrogen, here you just have to write H, the symbols, that's all like that. Then what do? Hydrogen, the atoms, it's 2 this side. What about on your right hand side? It's 2. And then oxygen on your left hand side here, on the reactants, it's what? 2. What about on the right hand side here, on the products? It's 1. Obviously in terms of hydrogen, it's balanced, but in terms of oxygen, it's not balanced. So on the reactant, it's 2. This one you can't change it to be 1, no? So we're going to deal with the products now. We need to ensure that the oxygen with the product is 2, so that it can suit with these 2 we are having this side. So I'm going to add a 2 in front of water, these 2 here. Now when I add these 2, my hydrogen will increase. So this 2 is for hydrogen, this hydrogen, and it's for oxygen like that. So my hydrogen will increase, it will be this 2 times this 2 we are seeing here, it will be 4 for hydrogen. So this big 2 times this down to small 2 you are seeing there, it's going to give me 4. So here I'm going to have 4 atoms of what? Magnesium, also hydrogen. And then for oxygen, this side you're going to have 2. This 2 is for also for oxygen, so it's going to be 2 like that. So obviously in terms of oxygen, it's balanced both sides, right and left. But here we're having hydrogen to be 4 on the products, but what about on the reactants? So here you can add a 2 in front of hydrogen like that. So that's how you do it. And then when you're having these 2 big 2, this 2 times this 2 you're seeing down there, it's going to give us 4 like that. So it's even balanced now. So that's how you do it. Now let me do the last one. So this one, we are having magnesium plus carbon dioxide, which is giving us magnesium oxide plus what? Carbon like this. So the question is asking us to balance this equation, which is very simple, and I'm sure by this time you know what's happening. Plus carbon like that. So what do you do here? You need to you need to count the number of atoms both sides. So we're having magnesium this side, we're also having carbon and oxygen. So those are the elements we are having. So magnesium this side, carbon this side, and oxygen. So we need to compare on the reactants on the products. So on the reactants, magnesium atoms, the magnesium atom is 1, carbon is 1, oxygen this side will like 2, then magnesium this side it's 1, carbon it's 1, and then oxygen this side 1. So have you seen, in terms of magnesium and carbon on your left hand side, it's the same with magnesium and carbon on the right hand side. So in terms of magnesium is balanced, and carbon is balanced, but in terms of oxygen it's not balanced. What are you supposed to do? You need to ensure that the oxygen the oxygen of which one this oxygen which is on the product should have what, 2 as well. So what do? You can add 2 in front of magnesium oxide as a compound like that. But what, when you add these 2 in front, it's going to then affect the magnesium. So this one for magnesium here, we're going to have 2, and then oxygen is going to increase by 2 as well, like that. And then have you seen what's happening now on your, in terms of carbon it's balanced, and oxygen it's balanced, but the problem here is now on magnesium of the reactants. Or here we're having 1 on reactants and we're having 2 on the product. So what do? You can add 2 in front of magnesium on the reactants, and then you're going to have 2 here now. So it's now balanced now, this side and that side. So that's how you come up with a balanced what equation. So as simple as that. So this is your task. You can balance the following what equations. So you're having A, B, C, D, E, F, and what, G. So you can submit this work, and then if you're having some challenges, don't hesitate to contact me. And then for online lessons, you can contact me. And lastly, don't forget to subscribe, like, share, and what, comment. And thank you for watching.